So the last section that we have to cover in Chapter 5 before we're ready to test has to do with graphing inequalities. Now we've graphed inequalities before. We've graphed them when there's only one variable like x. We solve it all down and we put it on a nice number line with an open dot or a closed dot with an arrow, stating that the solutions could be either equal to or less than or greater than that one point, and then going on either above or below, saying all of those answers would work also. Now what we're going to learn that's a little different from that is that now instead of having just one variable like an x, we're going to have two variables. We're going to have an x and a y, and we're going to focus on equations that are going to give us a linear pattern. So instead of worrying about curves or something we haven't seen, we're going to start off with something nice, linear. You guys should know how to graph it. And we did it in the last unit, so hopefully it's not too far back in the noggin. So the outcome of graphing these inequalities are going to look, or could look, something like this, okay? They could have dotted lines or solid lines. And there's always shading. The shading is either below the line or above the line. And we're going to talk about how you determine which lines and which shading to do. The general rules for inequality graphs that are going to be linear, as far as deciding whether it's a solid line or a dotted line, is all dependent on the type of symbol that you have as an inequality. Just like when we're doing it on a number line, if you have an open dot, then you would have a dotted line. So this would be our less than or our greater than symbols. Okay? Similarly, if it's going to be a solid line, it would be like our filled in dot on the number line. So it would be our less than or equal to or greater than or equal to signs. So automatically, when you look at the inequality, you're going to know, is it dotted or solid? Okay? Just like if it was on the number line. The shading is a little bit trickier, okay? If you remember, it kind of depends on where the variables are. So we're going to go over a specific strategy where we use the origin to help guide us to figure out where we are or are not going to be doing some shading. All right, if you are asked to graph an inequality and it has two variables like x and y, it's not as tricky as you think it would be. You're going to start off by graphing the line, determine if it's dotted or solid, and then we're going to run a test on this equation to see whether we shade below or above the line. Let's start by graphing it, because that's something we should already be pretty good at. This here is in slope-intercept form, so we see this is our slope, our m value, and this is our y-intercept, our b value. Okay, and this is a review from the last one. We're going to start graphing our line at our b value, positive 5. 1, 2, 3, 4, and 5. There's our y-intercept. From there, we're going to use our slope, our rise over run, to get the pattern of our line. So I'm going to go up 1, forwards 2. A few times, fill up my graph. And I'm going to go down 1, backwards 2 a few times to fill up my graph. Okay. I can see it has a positive slope because it's heading up left to right. My y-intercept is correct, and my rise and run look good to go. Okay? Now, just like we just spoke about, we're going to look at this symbol. If I look at that, it has no equal sign under it. Because there's no equal sign, our values can never fall on this line. They can either be above it or below it, but never fall exactly on it. So that means I'm going to have a dotted line. That tells our reader of the graph that the values cannot equal this. So I'm going to make it pretty obvious on my graph. I'm dotting right through those points, all the way across. Okay, that's only half the work. The next part is where it can get a little bit tricky. Okay, we need to determine if all of our values are going to be shaded up here, meaning that any answer up here would work. Any coordinate pair or xy value will satisfy our equation. Or if down here, any of the coordinate pairs or points that exist below this line are going to be fulfilling our inequality. The way that we go about doing that, in my opinion, the easiest way, is to focus on one point down here. If I plug in the value for that point for x, the value for y, and it works, meaning that my inequality will be true, then I'm going to shade wherever that point is. If it's below here, I shade below here. If it's up here, I'll shade above. Okay? I can pick any point I want, but there's one point that's going to work easier than any of the others. And the one point that's going to work easiest is going to be right here at the origin. Okay? The reason why this is easiest is because it's 0. It's going to cancel stuff out. So our coordinate pair here would be 0, 0. This is for my x, that is for my y. So I'm going to take that point, I'm going to plug it in, and see if it's true or false in my inequality. 0 for y, keep my slope, 0 for x, and my y-intercept. Now I'm just going to solve this down and see if I get a truth or a false. 1/2 times 0 is 0. So now I have 0 is greater than 5. Well, is 0 bigger than 5? The answer is no. That means where this point in is false. It is not shaded. False. No. Okay? Above this line, then, is going to be where I lightly shade. Okay? So every value that falls not on this line, but above it, would be a coordinate pair that would work. Okay? You don't need to write this down, but I want to prove to you that one of these pairs is going to work. So let's pick this one right here. Okay, this is point 1, 2, 3, 4, -5, 1, 2, 3, 4. So my coordinate pair would be -5, 4. I'm going to plug that in for x, that in for y, and I'm going to prove to you that this point does work, that it's true if I plug it into my equation. So my y value is 4. Keep my slope. My x value is -5 plus 5. Okay. Now I'm going to multiply 1/2 times -5 is -2.5 plus 5. -2.5 plus 5 is a positive 2.5. I'm going to bring down my 4. Is 4 greater than 2.5? Well, the answer is yes. 4 is bigger than 2.5, which means that, yes, this point is in the half that is going to be shaded. Okay? Hence why I shaded above that line. That's a nice way that you can always check to make sure that you did shade it in the right spot if you're not exactly sure. The last inequality we graphed isn't really that bad. I mean, it was graphing the line, making it dotted or solid, plug in a point, and see where we shade it. Sometimes, not often and not always, you're going to run into an equation that is not already in slope-intercept form. Now, we've worked on changing the forms to get different key features out of it. So we're going to easily and quickly, because this one I chose is pretty easy, change this to slope-intercept form so that we can graph it, again, quickly and easily. So looking here, this is actually kind of like standard notation. We have our x and y on the same side, and our x is positive. I want to change it into slope-intercept form so I can graph the intercept and do the slope pattern, and I have it done. So the only thing I really need to do for that is get y alone and positive. Right now it's negative, so I'm going to add a y to each side. I'm left with 2x is less than or equal to 7 plus y. Now y is positive, but it needs to be alone, so I'm going to subtract 7 from each side. When I do that, I'm going to have those cancel. I end up with 2x minus 7 equals, not equals, is less than or equal to a positive y. Now this is in slope-intercept form, where 2 is going to be my slope, and -7 is going to be my y-intercept. I'll graph it, starting at -7. So here's my origin, down 5, 6, 7, boom, y-intercept graphed. Next, I'm going to do my slope. My slope is like 2 over 1, rise 2, forwards 1, rise 2, forwards 1. Continue that pattern up most of my graph. And if I want to, I can do a couple below in the opposite pattern. Okay. All right, so now I have my line. After I've graphed the points, I'm going to ask myself, is this going to be a solid or dotted line? And I determine that by looking at my symbol. If it has the equal to underneath, it is a solid line because my solutions could be above that line, below that line, but also on the line. The line itself is a series of solutions to this. So I'm going to make it a nice, solid line. Boom. Okay? Now my line is graphed. Next, I need to decide, am I going to shade above? Am I going to shade everything below? So I'm going to pick a point, plug it in, and see if it works. Point, that's easiest to do. Right here, origin, 0, 0. If this is true, then I'm going to shade everything above it. If this is false, I'm going to shade where the 0, 0 is not, everything below. So I'm going to rewrite this. 2x minus 7 is less than or equal to y. To solve this, I'm going to plug in 0, 0. So I'm going to have 2 times 0 for my x minus 7 is less than or equal to 0 for my y. That cancels. I have not just 7, but a negative 7 is less than or equal to 0. So I'm going to ask myself, is that true or false? Is negative 7 smaller than 0? Well, yeah, the answer is that this is true, which means that this is part of my solution. So I'm going to shade where that point falls. It happens to fall above the line, so everything above this, even all the way over here, okay, this is all the possible solutions that would work with this inequality. Now that we've gone over how to graph a couple of these, I want you to try them on your own. But before you do that, I think there's a few on the bottom of your sheet. I want to go over, kind of summarize the steps that we followed first to get these inequalities. Okay? The first thing we did, if we're thinking of the steps that we have to do, is I like slope-intercept form, so I changed my inequality to slope-intercept form. That way I know what my slope is, I know what my y-intercept is, and it's really easy to graph it. After doing that, I graphed my line. But once I graph it, and while I'm graphing it, I should be asking myself, is it dotted? Is it solid? And I determine that by my two symbols. If they have the equal to underneath, it is going to be a solid line. If there's no equal to, it's just greater than or less than, it must be dotted. The last thing I must do is shade, okay? And the shading, there are some shortcuts somewhat to it, but I really think you would benefit from plugging in 0, 0, okay? And solving. Plug it in, see what happens. If you get an inequality that is true, you shade where 0, 0 is. Okay? If it's false, or if you get an inequality that isn't actually going to work, you're going to shade where 0, 0 is not the other side of your line. Okay? So change it to slope-intercept form. Determine what type of line it is when you graph it. Then you have to shade because you have a set of solutions that can work. You plug in your origin, 0, 0. The only time that won't work is if that's on your line. Okay? Plug in those values. If it's true, you're going to shade where the 0, 0 is, whichever side of your line it is. If it's false, you're going to shade where the 0, 0 is not. So if it's above your line, you shade below. If it's to the left of the line, you shade to the right. Okay? You do wherever it is not if it's false. Hopefully, this will be a pretty good summation and you guys will do okay on those couple of practice problems. Like always, we've done a few flips lessons before. If you have any questions about it, I'm here early before school starts. I'm here after school most days during the week. Or you can ask me in class if you have any questions before we get started.